Let's go through LeetCode 649, Dota Senator. For this question, it gave us string Senate. And for this kind of string, it has a character R and D in it. So you see that there are two parties. One is an radiant, another is dire. So that means those kind of senator, they are from R party or from D party. They execute their rights in this kind of Senate order. Let's look at the example two. So for example, RDD. That means the first one is from Radiant, and he has option to to execute his right. Then the second one is from Dire, and then he or she has the options to execute his right. The third one is also from Dire, and can execute the right. The so for the right, um, how can we what how to execute his right is exercise the right is ban one senator's right. So a senator can make another senator lose all of his rights at this and all of the following rounds. Um, so and another is announce the victory. If the senator found the senators who has the right to vote all from the same party, he can announce the victory and decide on the change of the game. So it return who in the end who wins, which party wins. So um here there are some kind of strategies. Let's look at the example, right? Example two. The first senator is coming from Radiant, and he ban this kind of senator, right? So this is still at round one. So the first one, he ban this, and the second senator, because and it's still bound round one because this one is from the Dire, and he is banned. He does not have options to execute rights from this round. And let's go through still the round one. This center hasn't finished yet. This is from Dire, right? So he has a right to um to ban senator, right? So we know if every senator is rational, um, they should ban the other team's senator, right? So this kind of senator, we're going to ban this R again, right? So in the first round, after the first round finished, this kind of first R and the first D is banned. And now go to the second round, only this kind of D at index 0, 1, 2 is left, right? So we'll say that this party wins. So first thing is that any senator, if there is still some other party senator left in the team, what he will do is ban another senator, right? So the second thing we want to say is that um, if we senator from a team, he want to ban another senator from another party, right? So if there are two, for example, I'm an R, right? There are two Ds to um he can ban. So which one should this kind of radiant select? I would say optimally, he should ban the earlier or which is have a lower index star senator. The reason is that um, um, reason is that here uh if let's look at the example if radiant, right? There are some kind of dial after him hasn't exercised right. So which one should he ban, right? The first one will be better. If they are after, right, this two doesn't have too much differences. But for example, there is another R here, right? If we ban the first one, so for our same team, this R will never be banned, right? So this will be some kind of optimal strategy because in the same round, for example, this D will never ban this R. So if I am a R, right, of course I want to ban the earlier D party, right, member. And um and so um um so this is in the same round, right? So if a party he want to ban another party, he want to ban the earlier one, and if for example this R already exercise his right, right? He goes to the next round, and for this kind of D, now this one also exercise its right and still alive, right? And now, for example, this D is trying to um, um, exercise his right. So, so who should he ban, right? So there are some kind of choices. If there are still are in the same round, right? Um, so he should better ban this R because he will be the person in the R team who will exercise the right first. So 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 what we thinking about is that for any R or D, they want to ban is that he is going to ban those kind of person who can exercise the right after him. The earlier the better in a different party, right? So we'll say there are two kind of dimensions. One is round, right? Another is index, right? So those kind of um, options for a senator to ban is that if round is smaller, right? Of course, we want to ban those kind of round. For example, this because those kind of even this kind of index, even they are smaller, but they already exercise their rights. The next time they exercise their right will be when all of the R members finished, right? So that means um, we want to ban those kind of person in another party who exercise earlier. So that means so the round, if a round is smaller, right? We pick the smaller round, and in the same round, what we need to pick is index, right? So that means if in the same round, they are if we already exercise D here, right? And if we exercise here, means those kind of R's, if they are still left, that they are already go to the next round. And in the same round, for those kind of R's, who we want to ban is those kind of with smaller index, right? So so we'll see there are two dimensions. One is round, another is index. Um, and in the end, right? So um, we want to see which which party still have members. Those kind of party who has members will win, right? So that is our basic concept. Here are another thing to consider, right? Because we want to go through um, R party and D party separate, right? Because the R party members, they are going, for example, if we ban some person, what we want is use a data structure, then throw that away, right? And in D party, right? They also have the same feature, right? So we should have two different data structures. And for those kind of data structure, what we want is because the every party they want to ban another party who exercise earlier, right? So that is some kind of first in first out data feature, right? And also the person who exercise those kind of rights has also first in first out structure. So what we're thinking about is that we use two queues, right? Two queue. One is for example DQ, right? Another is RQ, DQ and RQ. So RQ, DQ, RQ will be radiant Q and DQ will be the direct Q, right? So what we're thinking about is this Q, we need to put, for example, round and also index two meters into each queues, right? And actually, for this one, we can do a small improvement, like a two-dimensional. Sometimes we can convert to one-dimensional, like we use row multiplied by the column number plus column, right? So we can every time we go to the next run, we just add n, right, to it. So we can instead use a int array. We just have a number to put into this kind of queue will be enough. And so that's what we compare. We don't need to compare the round, right? And index separately. We just count those kind of round multiple by n plus index this number directly, right? So let's write code for this. As we talk about, we need two queues. So we need for example, queue. We just need integer, right? So RQ equals new array that, and also DQ equals new array that. So what you do is that let's just get this one as cherry for senator to char array, and let's have a length n. So what we do is for int I equals 0, I smaller than n, I plus plus. If array I equals R, right? That is from radiant. So RQ will offer I else. just a DQ offer. So what we do is that while this kind of DQ is not empty, right? And RQ is not empty. Then we are going to check which one has smaller number, right? And we'll see we in these two queues, which one has two smaller number. And the thing is that the smaller number one is going to exercise his right? And what he do is that he just ban this person. So ban is just like throw this data away, right? And for this person, he exercise his rights. What we do is add to the next round. So next add to the next round is just we add in, right? So that will still add to the same queue. So both options, we'll see. We can use a pull method to get them out. But for this one, we don't need to enqueue, right? But this one, we need, a smaller one, we need to enqueue. So let's say we're going to have int r node equals rq dot pull and d node equals dq dot pull, right? So what we do is that if r node is smaller than d node, then r from the radial party, this kind of person, right? He can um he can exercise his right. That is for D node, just throw away. And for R node, he will add to a new round, right? So add a new round is just R node plus N, right? And else that is DQ over D node plus N. So in the end, what we are going to retain is which queue still have the data, right? So when we jump in out of this kind of while loop, one queue will be empty, and it cannot be both queue be empty because we have offer in queue options, right? So at least one queue will have data, but when we jumping out of this kind of while loop, another queue is there should have one queue being empty. So return. So for those queue which has node in it or signature in it, that will be win, right? DQ is empty, then that is radiant. Otherwise to be dark, right? And let's also write the Python code for this. We need a queue data structure. Let's write from collections import deck, right? So we are going to get its length, right? Int n equals the length. Okay. And rq equals deck I mm, I for I then in enumerator senator if sen equals r, right? And deck dq equals deck if this equals d, right? So what we do is that while RQ and DQ, then R node and D equals RQ top left, and DQ top left. So what we do is that if R is smaller than D, then we're going to have a RQ append R plus A, right? Otherwise, else DQ append D plus A. So what we return is return radiant if RQ else star, right? So this will be the code. The time complexity and space complexity will both be O(n).